I think I think I may have cut Max off. Um, but yes, here I am. Today I'm coming up for abilities for just a little bit to just take care of like a little queue of backlog of cosmetic things because we're gonna be hauling our build to Dragon Con and some other places real soon. So right now I'm getting to work on shinies. So let's see. Pull up the game, and as it loads in, what we see here is this is kind of like a worst case for like evil, crappy lines in the terrain. By the way, levels right for everyone. Like everything coming through at about the right volume. I got to put up one little thing. Someday I'll figure out my mouse and spelling. Okay. Gotta give a shout out to my music now. Um, okay, so here we are with. Oh, you don't hear the music? Why do you not hear the music? Clearly, I need a new music player. BRB. Um, Everybody should hear that now. Okay. So again, let me know if let me know about balance and if things are too loud or too soft, and if you can hear me over the music or not. So, here's what we are looking at right now, and this is going to be just a day of fixing random graphics stuff. You can see these nasty little crap in the terrain where textures have been assigned badly, and what's going on there is at every vertex you're allowed to have however many textures, but on any given triangle face our shader can only draw 4. And what's happening in places like this is the art team has made things where sort of unconstrained, and the game is doing a really bad job of chopping that stuff down to what the engine can actually render. So I'm going to be doing a giant, great big bass of reworking how we assign terrain textures today. By the way, just to something you might not have noticed, remember all those nasty scenes in the geometry itself? You don't see them today, so I fixed that this morning as part of our big all-purpose cleanup. So, and I do not know why there is a floating bush right here. That's a thing to definitely go talk to Tyler about the floating bush. Or maybe Ben. Maybe the bush is Ben's fault. But this stuff here is my fault, so I'm going to go fix that. And as part of that, the first big thing is stop trying to solve the problem of terrain textures at the vertex level and just say, well, the problem is we can only have so many per triangle, so we need to do our assignments in a triangular way. And just because it's prettier, I'm going to set my client to the golden hour. And jump into Visual Studio land. So, this is going to be a pretty technical kind of day, but hopefully it'll be entertaining to some of you. Here is subdivision renderable, which is a giant file that takes terrain data and turns it into meshes that we can actually render, and it does a lot of arguably overly complicated stuff. And I think there might be some simpler code to do this thing. Sometimes the best way to do things well, sometimes you've just gone down this path of making things so complicated, and finally you realize the thing I need to do is actually just take a new approach that will not have nearly as many special weird cases, etc. So I'm going to just say, hey, here's data for assigning textures to vertices, and then I'm going to write the definition for that. See, priority is going to be just a saying of how important this vertex is. Vertices on the edges of the mesh for a given section of terrain are actually going to be more important to preserve their original textures than the ones in the middle, because that's where we will be lining up against matching terrain segments. So, let's see. Then, Texture weight is a really simple little data structure that's just what texture number and how much weight is there. So, and small vector, by the way, it's like a C++ standard vector, except it sort of contains built into it space for a few other. It contains space in there for like up to, in this case, 6 unsigned shorts, so it doesn't actually go out to your memory allocator to grab memory unless you use more than that many. And in games, we always try and be like super efficient in real time, so small vector is a great utility to not put any load on the memory allocator in the common case when you just have a small set of items. Let's see. That's probably enough stuff right now. But so now I'm going to write a couple little utility functions for this. And this is going to be a function that is going to just take a vector of textures and merge and sort them so that, if you have like texture 3 in several places, it'll all come out, it'll get merged down into just one. So, just call that V. And I have to templatize this based on the vector size, so I can make it work on whatever size vector, which is not ideal, but actually, so let's see. And now I'm just going to go through and sort and merge this. This is not, so, this is basic programmery stuff. If you, need to do a programming test of how to sort things, I'm about to do that. It actually does happen. So I'm going to take I and move it through, and this is just going to look like a slightly fancier selection sort, I believe. Let's see. And so, actually, now if this one's invalid, then what we'll do is that'll sort of pull that down and replace it with the last. Well, that'll move the one at the end into that slot and just replace it, and then otherwise assume we have a valid one and now we got sweep J to the end if J is less than then what we need to do is swap the things at I and J, and then Yes, I'm using goto. Sometimes it's easier than like double breaking out of a loop. And then as you can imagine exactly how complicated the loop control logic would have to be to not have that goto. So if these are the same ones, then so in this case we are merging two of them, and then we are saying and in that case we are getting rid of the element at j, and the last case, well, j's got a texture number that is higher than i's texture number, so therefore we just want to increment j. And so at the end of this inner loop here, we will have either found something that needs to be ahead of I in the list and swap that with I, or else we will have found, or else if nothing is smaller than that, then we will have swapped all of, we will have merged together everything that's the same texture and left everything else alone. And we come to the end, and J is finished. So now finally, if there are, now that we've added together everything in I, actually, if not I is greater than 0, what we will do is, well, so if I is greater than 0, then we just move on to that. Otherwise, we have something that does not actually contribute to anything, so what we do is we get, we say, and once again we just pull the end element in there to splat it, and we leave I pointing at the same element. And then, so this total loop as a whole will leave us with everything sorted by texture number, and everything that has the same texture numbers will be merged together into one element, and anything that does not end up with a weight that's greater than 0 will just get eliminated. And actually I'm going to throw one more in here, and we want to renormalize the textures. Yeah, actually we probably don't. Yeah, we don't want to do that just yet. I'll make that a separate thing. And then, so last of all, what we need to do is clean up the end, because in a lot of cases we might have decremented the end to fill in spaces. From the vector, we erase that range, and ta-da! Oh yeah, one more thing to tack onto the end of that, just static, because we want to have this live in this file. So now I'm going to write my renormalize function here. Actually, I'm going to take a page out of literate programming and say we'll return the input. And that's a thing that lets you easily chain together functions and make a little pipeline of stuff for convenience. So, you know, if I also make this one do the same thing, then I can do things like, you know, ta-da! So this one's going to be way simpler, I think. I'll copy some of this same code. Except and in the case where it's 0 or just nan or infinity or something horrible, we will say and get rid of that. Now, total is greater than 0, else we just clear everything. Actually, in this case, we're just going to say if it's off from 1.0 by more than a tiny amount, then we need to go through and divide it. So what's going to happen at the end of this is everything is going to end up with a total that's exactly 1.0 if you add everything in there. And drop this little bit of code back in here to, if we got rid of some, then we'll clear it, and now we'll return v. Actually, let me check the code for that. Small vector erase. Here's what that looks like, and actually it's doing if first is less than last in the very start, so it's going to be kind of trivial, so I don't even really need this. Most of that code is assertions anyway, so that will get compiled out in the release build. So yeah, now I got to normalize and merge and sort, so I can manipulate little arrays of texture weights much more easily than I could before. And brief trip over to chat. So, just catching up on the Twitch chat. Okay, thanks everyone. I basically feel like I'm, teaching Latin lessons, but hey. Hopefully I'll be entertaining. I can wear a funny hat, if that'll make it funnier. This is how we code. Coding Fez on. Okay, so having written those little stubs of things. I think the first thing that I need to do is so I have this giant call to make renderable verts, and this is where the weird things happen. So I'm going to add a data structure for an ordered map from the coordinates of a vertex to make that a scratch unordered map, because this is all going to be very scratch memory. And again, that's something that we have to care a whole lot about when we're designing games, of just when and how to use memory, because every time you hit that memory manager, you are potentially, blocking other threads that are also using the memory manager. You're fragmenting things, which in a game that's meant to stream continuously and run forever instead of have levels, you have to try really hard not to fragment memory. Giving this the very creative name of Vertex map. Again, reserving space in all of your arrays is important. Actually, I'm going to go a little farther and say I'm just going to make my own say terrain build vert. And this will become a terrain build vert 2, and actually what it should be is a and I'll grab some things from the original build vertex that are actually relevant to this. Yeah, we don't need the rest of this stuff. Well, I guess we do. We need a little bit of this stuff. So here's, we only need one texture coordinate, and we only need one set of texture tangent vectors, and that's our whole terrain build vertex. and we use that. So we won't even have a vertex map anymore. And then this function addVert can change to modify that. So it'll take a terrain build vert as its parameter too. I'm going to get rid of a lot of things related to the data we weren't using before. Leave snow off until, this winter when we put snow back in. So let's see, I'm going to get rid of this stuff, because that was the old version of assigning texture coordinates badly. Let's see. Oops. Alright, we are going to need to here's where we figure out the normal, and this is not the greatest way to figure out the normal, but I'm going to leave it there and solve other problems today. And I'm going to get rid of that code. See, all of this is crap because it's making things look ugly. That's all making things look ugly too. That'll copy that in. The reason we have this texture blend vector type up here is that initially coming out of the terrain mods there may be like huge amounts of stuff, so it's set as 24, but then once we merge and sort, we will get rid of most of those, I hope. So, let's see, we only have one tangent here, so I'll get rid of that. And that's more stuff that's just dumb. And always nice to move things. Move will avoid making excess copies of things. Yeah, in hindsight, this is also a really dumb way of looking at the texture tangents, so I'm glad I'm glad I actually took the time to look through this code. So I'm gonna, at some point in the future, I'll rework both how we make texture tangents and how we do the normal to do things in a better, happier, more global kind of way. And I'll take a second to catch up with the chat. Okay. Yeah. To echo what Absalom33 said, if you just want to play a game, the best thing to do is to go jump in and get beta 2 or even beta 3 when the game is getting close to done. If you want to be first-hand part of a game's development, buy an alpha tier now. That'll be awesome. But you'll get to see a lot of broken stuff. You get to see me fix things. Yeah. Oh, oh, everyone was talking about the logo. Yeah, the logo on my hat is the classic Star Trek engineering team logo. Yeah, there are multiple different Star Trek insignias for the engineering team and the executive officers and all that. So yeah, this is the engineering team fez from classic Kirk and Spock. Let's see. Let's see. What did I say about stuff that prevents memory fragmentation? So, first, a little primer on memory fragmentation. You've got this big thing of here's the memory in your computer, like here to here, and say, all right, we grab this chunk of memory and use it, and then we grab this chunk of memory and use it, and then we get rid of this first chunk of memory, but so you've got like a big chunk of memory in use and little small pieces on either side of it, so you don't actually have enough memory. So even though there might be like, a gigabyte free, you have it in the form of like 700 megs and 300 megs, so you can't actually use a gigabyte of memory in one block, and that's what memory fragmentation is. And the reason we want to avoid memory fragmentation is that you end up, over time, if memory gets really fragmented from not paying attention to when and how you allocate and deallocate things, it ends up chopped up into little pieces, and eventually, even though memory's not, quote, leaking, you might have, a gigabyte of memory free, but you can only use it in, let's say like 20K chunks or something, and that was a big problem for, say, the Warhammer client, where over time it would, even though it wouldn't leak memory and it wouldn't run out of memory, it would get to a point where the memory it had was so fragmented we couldn't allocate new memory. So, yeah, so we try very hard to avoid that, and that's something that I learned even more about during my time as a console developer after Warhammer. So one of the things we do to avoid allocating and deallocating memory is say like this code right here, where we just start off by, well, we need vectors and data structures, and we just say, instead of start out empty and just grow it as we add things into it, we say, hey, reserve enough space for this that's going to cover however many things we're eventually going to put into it. Another thing, and that means, instead of like, well, we put in 5 things and it grew to fit 5 things, and then we put in a 6th thing and, all right, so, well, we'll allocate enough space for 10 things and the next 5 things will go. No, it starts off with the right size. The other thing is these scratch structures. Like if you do C++, you're familiar with things like unordered map and vector and multi-map and all of those. And all these they're a template type def that is a normal unordered map, just like you would use normally, except it's going to city-state's scratch STL allocator, and that redirects all the memory allocations and deallocations into a fairly complicated separate pool of memory. It's like, if you can think of, like, over here on the side, here's a section of memory that we reserve just for like scratch use, and so you can allocate and deallocate a bunch of stuff, and without fragmenting the big main memory for stuff that's only really, really temporary. And so that's another main thing we do to avoid fragmenting memory. Finally, up here at the top of the file, I use these things called small vectors. And if you're familiar with a C++ standard vector, or in C#, it's a list. It's a container that you can just, it acts like an array that will grow over time. But because it's a small vector, what we have is built into it. It has a little array of things. So until you put more than, in this case, 6 items, it won't go out and allocate memory. So anything you can do to keep your memory contained in one small area instead of allocated off in a whole bunch of different fragments is going to be really, really helpful for not fragmenting memory. So, yeah, that's my long sermon about how memory fragmentation gets prevented for beer chug. Gosh, I could use a beer chug myself, but okay. Let's see. Catching up. Any more questions? Let's see. Oh yeah, the always the joke about 700 megs, 300 megs. So in college, way back in the IRC and AOL Instant Messenger and all of that days, my online name was 2 megs because I was like, well, I can't just be 1 meg because it's megs and it's plural. So I was 2 megs on IRC, and then finally at Mythic, like my fantasy of, oh my gosh, my dream perfect woman, 1 meg. I met 1 meg. And unfortunately, we didn't like each other, but it was like, this was meant to be. Oh wait, nah, you're just a cool person. It could have been so perfectly nerdily romantic. Alright, yeah, me huge. You read some Dr. Dobbs journals. We also do that. We have a full custom memory allocator, and the design's heavily influenced by the one from Skyrim, because I wrote most of Malak in Skyrim, and came out and said, what can I do even better with the clean sheet of paper? And that's most of what's going on this. And in some cases we've seen some great performance type things, like for Rob's building code, when it's calculating like build-in stability on the server, it's like a 3 times improvement in how fast we can figure out a building will fall down or not just by using our memory allocator. So that's neat. And Lottoing, it could be any other combo, I just happened to pick those numbers. Okay, so what is my favorite thing to work on? I can't answer that. It's always something new. Like if there's one thing that if I've already done it, then I'm like, why am I doing this same thing again? But in general, my heart is with graphics. My least favorite thing to do is probably network code and serialization type stuff, but it's got to be done. So anyway, back to make renderable verts, where advert just got a whole lot simpler. Actually, we're going to need a I need to add one more parameter to advert, which is I have to say that what the priority is, and that's going to be something that's really important for in a second when we start saying, all right, when there are more textures than we need on a triangle, what's gonna take priority over what? And here we'll go with the maximum of that, and gotta add our parameter back in the header. Let's see. So we're going to have to keep track of whether we're doing this on the edge, and let's see. If we're not on the edge, then the priority will just be 0. Else, if we're in the corner, then the priority is going to be 2. Otherwise, if we're on the edge but not in the corner, priority will be 1. And we will add that in with the priority we just picked up there. And these can get priority 0. And we'll worry about that later. This is some legacy code, but I'm going to keep it maintained. This was meant for handling more arbitrary meshes than this. Okay. Let's see, add try needs to be changed to take the terrain build verts that we've just passed in. Actually, we probably don't even want to do that yet. What we want to do is sort of buffer up all the triangles that we have. Let's see. So what we're going to do is, now that we've pulled all of these together, we're going to try and come up with a list of textures for everything. So I'm going to change add try to something. Just make a new add try. Come on, Visual Studio. Go, go, go. Actually, I'm gonna say we need a terrain build try too. I'm not sure what's going to be in this yet. I'm going to figure it out as I go. So I think perhaps a good thing to have in there first would be and we'll put that in there, and we can safely use pointers because we know that we are we will have added all the build vertices first. And then we'll have the out being the final ones, and I'm not sure what else we need. I'll figure this out. We'll probably end up adding a vector of textures as we go in there too. So and let's see, this vector can just go away. We're not even going to use that anymore. Let's go to this add try and make it do something useful. This thing shouldn't be a const because we're going to modify it. Okay, preverts, set that to 1, and then triangle number equals tries point size. And here we're just setting up the little pointers, and it's important because we want to actually modify this vector anymore, so it's a small optimization. Fix my spelling because I like spelling. might as well grab all of the textures for this now. Actually, I'm thinking, what can we do in this pass rather than a later pass? So we can resolve some of our textures. So over here we're getting the highest and lowest priorities from there. And we will step down and do some resolution on all of these, just the super simple way. And then so here we're going to have an array of up to 3 of these, and let's see. What am I doing here? I'm designing an algorithm on the fly, basically, and I don't know exactly how this is going to look, but I have a pretty good instinct, so I'm looking at what the highest priority vertices are, so we always give them first shot at Let's see. See. So I'm using the final textures. I'm going to go back and change that to working textures. Or maybe I can do it now. Or just name it textures. And then up here in advert, up here in viewport advert, I'll also assign that. So I need to write another function, which is just given a vector of some number of textures, chop off everything but the least in textures in there. And that'll be one where we've already run merge and sort and probably normalize on it. so what we'll want to end up doing is just chopping everything off. Merge and sort by texture, and we'll also want to merge and sort by weight. And that assumes we've already merged and sorted by the textures. Alright, so sort and clamp by priority. And we'll say pass in the max size. Have the nice early out. J has a higher... Oh, come on, why are we confused? Actually, at this one, there's nothing special here. I'm just going to standard sort this with... And now that we've resized it, now that we've sorted it, we'll resize it. And we probably want to normalize it, but... probably not a problem. We'll keep that a separate one. Make this look nice. There. happy little lambda. So back to where we were writing our texture code. Let's see. We're just going to say you get a limit of 3 on any one texture. Then finally, so what I'm going to do here is this loop is kind of the heart of what we're trying to do. So we're going to, if we have some that were already in there as a higher priority, in the texture vec, we'll set their priority to infinity. Then we'll accumulate everything that was a lower priority, and then finally we'll sort and clamp by priority. And what that means by doing that is that when we come in and sort it, the things that were already in there at the start will not be the ones that get clamped off. Actually, that's probably the wrong thing to do. Because infinity is always infinity, so instead I'm just going to add a very large number. That way, in the event that we overflow, we don't get into a case where, well, everything is just infinity. There will still be some way to prioritize it. And of course, the things that were in there twice, if that ever happens, will get prioritized even higher. And so here we've got a list of textures that we can actually use on this triangle, but so now we want to go back out to the but this and so we could take these and reassign. This is the heart of it. This triangle only has 4 textures on it, and we could go out and assign to the vertices, well, you get textures that are in that set of 4 and nothing else. But we still wouldn't be perfect because we have to, it could be that you've got 6 triangles around a point, and if they, if we reassign this vertex based on this, the textures in this triangle versus this triangle versus this triangle, then there might not be a common set among all of those. So that doesn't quite get us to where we need yet. I'm going to take a short mental brain break and catch up with chat for you guys. let's see. Wow. I was writing code for a long time while you guys were talking. So, not going all the way back. Let's see. Guys, you're awesome. Thank you for believing in us. I'm not going to get into all the stuff we're doing. Yes, wow. Okay. So is the terrain, well, one question, is the terrain hexagon based? The terrain is triangle based, which, you know, there's sort of between a grid of hexagons and triangles, there's a, you know, one or the other. The benefit of triangles over squares is video cards render triangles. That's, but you know, if you take triangles and you tessellate them out of a grid, you'll make hexagonal structures. So, so we're gonna say t dot. I'm gonna set that in the text spec. Which we will now add to that. And then, let's see. So here we have not yet actually assigned final textures to the vertices, but we have a list of triangles that we have a list of, for each triangle we have a list of textures that we think we want on that triangle, and then we have, you know, in each vertex we have a list of the triangles that are using that vertex. So somewhere between the two, we're going to have to make a final pass over the vertices and come up with a final assignment of textures. And I'm going to give my voice a little bit of a break and take 1 second to think this over. I will be absolutely right back. In the meantime, what can I show you? In the meantime, yeah, you get to contemplate the zen of the code. I'll be right back. anytime I need to, because this is the joys of being part of a small startup. While I am taking a break for a second from thinking about the code, I'm going to talk to our t-shirt printer about when we can pick up our new t-shirts, because there's a new logo for the game, and so there's new t-shirts for the team, which hopefully will, soon become new t-shirts for everybody else, but soon. Telling him something's coming is not the same as telling him what it is. They know it's coming. Yes, there's a new logo. I don't think... Yeah, I'm not sure you can hear JB is giving me a hard time. I've been leaking it. It's great. We've got like this huge banner now. It's sweet. It's hot. Okay. Yes, this is about blending the textures together in a way that does not have horrible, nasty seams on them. And I've spent a long, long time writing code, getting ready to actually turn that into something running on the screen again. Let's see. So, now we're going to write the function that does the magic. Resolve texture conflicts. And yeah, as soon as that function returns, we'll be done. Now I just have to write it. Like you do. going to do here is I'm going to step through for each vertex, and for each vertex I'm going to look at all the triangles around it and pick what their and look at what textures we ended up picking for those triangles, and then come up with hopefully a kind of union of, or an intersection of all of those. And once we finally got, and then I'll pick final textures for the vertex based on what we ended up with, based on what's accessible in all the triangles. So, one thing I forgot to do, before I forget about this, merge and sort by texture, sorting by priority, and then we'll normalize all of those in there. So, all the way down here. Do we have a nice constructor for this? Yes we do. Look at that. Nice convenient constructor. Text.emplaceback. So I'm actually going to just set this as 1. Actually, even better. Now, so we've, instead of putting in the weight on from each of those build tries, which the weight was nonsense anyway, actually it's nonsense in a really useful way. No, this is probably better. So we feed it in there at the priority of that, and then we will so what we've got in text is a set of all the textures that are used by all of the triangles around. And what we're going to try and do is resolve this down to stuff that exists in the most triangles. So basically we want to try removing anything from V's list of textures that's not in what we've got in text. So So we'll step through this and so for each of the textures we've got on V, we're going to go look and see if it's found in the list of textures on the triangles, which we truncated. So, you know, even though all of those lists originally contained it, because we truncated it up way up here, then we might have eliminated some of the textures on V itself. So So if this texture number equals the triangle texture, then so if we didn't find it, well, if we found it, then we can keep it, and so we just move on to the next one. Otherwise, so we erase that member and continue. And then now I have the question, did we find anything at all? Well, that's certainly a problem. So we'll just take whatever was found in the most triangles, or the highest priority of triangles, and well, we'll otherwise, So that's our fallback if everything got chopped out. But we're still not done yet, because now we've assigned a texture that was really to the vertex that was really, really popular with all the triangles around it. So it's probably something that, like you had one brown dot surrounded by a ring of 9 different shades of green, so we're just pulling over some shade of green there. But the problem there is that now that we've done that, the texture lists in all of those triangles are now invalid. So we need to go back and revisit those triangles and reassign their textures. And once we reassign their textures, then we conceivably have to go reassign all of the. We have to go reassign all of the yeah. You can see once we've reassigned the textures to the triangles, we have to reassign textures to the vertices using those triangles, which eventually, hopefully, we converge to something that leaves everybody happy. So we'll probably just set some threshold of how far we will go. But what that tells me is that to go back and make this function up here a thing I can rerun. So this little bit of code to assign the textures to the triangle that needs to become its own method that I can call again. So we'll assign try text from Vertex and would add a field in here that says textures dirty, and go in and add the vertex. We will say right here textures dirty equals true, and we'll do the same thing for the triangle. Let's see. Let's see. So when we say assign the triangle texture from the vertex texture, let's see. And when we clamp this, what we'll have to do is go through and say, just make some of these magic numbers configurable. That lets me just change these values with slash commands as I need to. So in here, change that to that, that to that. So here we've come in and we've clamped it somehow, and then we, for every vertex, so what I'm trying to do is when we assign triangle textures from the vertices to the triangle, we chop the list on the triangle, and then any vertex textures that are not satisfied by that, then we go and chop those, or then we set those to be dirty. so here when we do that, we set anything that we didn't find a texture for to true. I'm not sure if we actually need to do that. I'll revisit that in a minute. So, it might be useful though. So in here, when we resolve the textures for Vertex, what we want to do is, alright, well, we changed, we assigned this a completely new texture. We didn't just get rid of some of it. Some of the textures we actually, what we can do here is, so if we removed anything from this vertex, then we need to set all of the tries to say they need their textures redone. That is finally this one gets set to its textures are fine, and in here so here we have a thing to resolve any conflicts at the vertex level, and we'll set textures in the triangle level to being dirty anytime we make a change there. And then here we have a way to resolve conflicts at the triangle level, and we'll set any vertices as being dirty. So we can ping pong between these a couple of times, but we still don't have a guarantee that it's going to converge. But we're close enough that I'm going to run through this. So the problem is, again, we could just end up playing ping pong, but it's not. We'll get close. So actually, we probably don't want to. Yeah, we just want to do that directly. So we want to get the priorities in there. grab this thing and then oops. Alright, I need all of this thing. Okay, yay, t-shirts can be picked up tomorrow. You know, everyone's excited about that, and eventually, you know, I'm sure you'll get the Nugo leaked on there. So, alright. Almost done with this. So, just give this a name that makes these parallel make sense. So we start off reassigning textures from tritextures, go through all the tritextures, assign them a texture from the vertex textures, and then do this again. Okay, so each of these functions is going to return whether or not we invalidated the other one. So when we assign the vertex textures from the triangles, we'll return whether any of the triangles need to be updated, and vice versa. And magic is about to happen. So we'll start off with dirty equals false. So here's the magic that's going to make this converge now. So this right here, sorry, I got too focused and scrolled down. This right here, so we start off with how many textures, and then we run through, and if we dirtied any tries, then if we couldn't do our vertex assignments right, then we will go through and cut down the number of verts there, and I think that will eventually end up reducing all of the things down to just one texture per vert in the worst case. I'm pretty sure. Okay, so now we've actually, in theory, I think we've resolved all our texture conflicts, and that's the core of all the bad things. So I'm going to carry this on through until we actually... Now we need to just... Everything else from here is fairly simple, just pushing stuff out. So what we need to do is ultimately write all the build vertices out. So this is the mechanical stuff. We're just going to spit out vertices as we need, like you do. One triangle at a time. So loop over all the input vertices, and we are going to make pretty things. Let's see. For each of these, let's start off by So we're going to loop over all the verts we've already created for this, and initially that's going to be empty, but we'll end up adding some over the course of this list. up, and what I need to do is sort both the triangle textures and the stuff I need. So right after I do this, I will gotta put these in the order that we need. This comes up with nothing. Let's see. So that builds up our little set of terrain weights. Better optimization pass on this later. Actually, we don't even need that. So here I am building things into the set of output verts that we're actually going to send to the video card. And I'm going to step over that and okay, so now we've found possibly we found a matching vertex that has the right set of textures to be used on this triangle. The reason we have to do that is there might be like more than one copy of a given vertex. Like, say this one only has grass, but it needs to blend to mud on this side, and it has to blend to rock on this side. So we actually have to have two different vertices there, and the one that goes to this side that is part of the triangle on this side will say I am mud and grass, but mud is 0, and the one that goes on that side will say I am grass and rock, but rock is 0. So, did find a matching vert, then all we need to do is but if we didn't, we have to make a new vertex. Copy everything over. So I'm just going to pull up my definition of build vertex, and here it is. I'm going to pop it over to my other monitor so I can look at it side by side while I write this code. assign this, and this is almost done. Now I need to go through the vertex and get the actual weights for this. Finally, just need to finish out assigning everything in this array. It's possible this is done. we probably need one last pass of normalizing the weights. Because stuff might have gotten chopped down in weird ways. So, going through one last time and just normalizing these output weights that we have generated, because they may be odd and may be doing strange, beautiful things. And here we go. Let's light it up and see what breaks. I just got photobombed by Mark. Isn't that exciting? Okay. In hindsight, we can look at this entire function and say this function is crap and should go away. Well, that got rid of most of our compile errors. Yeah, that function's crap too. Let's get rid of that too. And fix our little loading it up. Yeah, take a look. See if this looks good. Maybe. I bet it's gonna look horrible, actually. There's probably gonna be a horrible, horrible bug. So while I wait for the build... Everyone's talking about McDonald's. Let's see, what does 0.0f mean? That means it's just being forced to be a floating point variable. What does this even mean? What? That has nothing to do with my client, Visual Studio. But hey, the client loaded. So let's see what the terrain looks like. It probably doesn't look good. Loading, loading, loading. It's possible I've done something in the terrain that leads to an infinite loop. Let's break the code and see where it is. Oops. Yes. This will run forever. Unless we start chopping down the number of textures. Yes, always gotta have that loop termination condition. Load it up. Load it up. Are we gonna go? Are we gonna go? Well, this is interesting. There appear to be large swaths of terrain missing entirely. I think I'm doing something wrong. On the other hand, I have definitely eliminated all of the unsightly lines in the terrain. I think this game looks awesome. I mean, I don't see how anyone could possibly have any problem with this. Yeah, this is perfect. This is absolutely perfect. I think we have nailed it. Yeah, pretty much if you don't like this, then you're a jerk who hates fun. Okay. Okay, let's figure out what I did wrong. Because this is not quite what I was expecting to happen. Okay, I predict that if I go... Let's see, I want to go south. So that means I need my facing to be about 270. I'm going to come to the place where all the terrain actually is living. Yep. Here we are at the terrain. So I have an amazing idea for a far more awesome game than No Man's Sky, which is we don't just have like procedural worlds, we have procedural code that will randomly introduce changes to the code on every planet and create bugs like this. So, you know, maybe you just end up in floating triangle world. And yeah, why wouldn't you? Why would you not play this game? Okay, so, seriously, I'm going to open up source tree for a second, and I think I deleted something that we needed. That's my theory. I deleted a thing we needed. Actually, I'm not even going to try and look at a diff because this is like diff everywhere. I'm going to just open up the old version of this file. Okay, here's the old version of this file. And yep, so that's this line right here is the one I needed. Alright, let's do this again. This time with, everything not like spaced out all through the world. So if I'm gonna talk seriously about No Man's Sky, personally, we're doing a ton of procedural worlds. Like, all of this terrain is procedural, and there are Tyler's and Ben are doing crazier and crazier things with it and stretching farther and farther. And I'm a big believer in procedural content as a way of building out the parts of a game that are interchangeable. There always has to be something that creates meaning. The heart has to come. If something is procedural, it's something that is, by definition, just interchangeable with something else. It's the same thing with a different set of numbers. The heart always has to come from somewhere else. So what we've tried to do with the terrain is build a system that's procedural yet editable. So you can, just come in and make, alright, and here's an island, and here's a mountain range, and they'll just be an island and a mountain range. They're sort of generic. But we've built an editing system that lets you go in and manually create points of interest within that, and then have the procedural stuff sort of adapt to the point that you created, because those touches are the parts that matter. Does it really matter in, like, say Skyrim? It doesn't matter where every individual blade of grass is, but it doesn't matter where every rock on a mountain it is. But the key mountain, the throat of the world, that mountain really matters. And so, how do you blend the two? How do you do something that's not all procedural? How do you save development time on the parts that are just sort of filler between the parts that are key? And and how do you have procedural stuff that's also editable? And that's what we've tried really, really hard to do with our system. And then hopefully you'll like it. And hopefully all the world will be back in exactly the... Oh! Alright, so, I'd say we have successfully gotten rid of most of the really weird stuff in the terrain, but we have not gotten terrain that looks good. Like, there's not super strange, crazy textures that come from nowhere. There's not... But this doesn't blend nicely, so I'm going to keep working on this. First I'm going to... And by the way, I have grass turned off, just to make it easier to look at the terrain. Oh, that's double not good down here. On the other hand, some of these things are a lot better than they were before, and some of these things are just gross. Like those lines are totally gross. Nobody wants those lines. So I'm going to go spot myself a really great example of something that's bad. Like this, right here. And yeah, I'm going to try and debug exactly what's going on these particular pieces of terrain, because I think I do have the right approach here of taking textures and of solving this at the triangle level instead of the vertex level, but I'm not doing it just right yet. So anyway, time to get another delicious Coke Zero from our sponsor, and I will be right back. Probably the thing I need most, and this is really kind of overdue, is I need a way to get the exact coordinate of the terrain textures that are underneath my feet. Because this vert right here would make an ideal thing to look at. So I'm going to look at my little stats display, 495.38. Yeah, I'll just start looking at verts that go into that area. So one little trick I do is in the file that I'm actually going to be debugging, I'll just turn optimizations off and make sure I remember to turn this back on. We'll just add all of that. So yeah, optimizations are off for this file, but I've made a note for myself, like you do. Extract this code out. What the? I have no idea what just happened. So something just exploded at me. Okay. So So I guess the first thing to look at here is what's actually being emitted. And I'm going to start going in and adding more and more debugging to this as I go. Turning my mic back on while the build finishes up. What did I use to make the code transparent? I'm using OBS as the Open Broadcast software. What it has, I'll just turn on my monitor capture instead. So here is OBS. Here's my Visual Studio setting, and the properties on that are I'm capturing Visual Studio, and I'm using a color key set to mask out the Visual Studio stuff. So that's nothing special or anything like that. A lot of this looks really good, but what the heck? Okay, so these places where we're getting super hard lines, that's what we need to work on. I'm going to jump in here and see if I can figure out what's going wrong. let's just jump out and see, start by looking at what do my mesh verts actually look like. So you can see right off, I have 3,666 mesh indices, looking at here, and the same number of mesh vertices, which tells me that the code that's supposed to match these up together is failing. Although that's a simpler problem than I thought. Just be a matter of just need to actually put that in the array. So let's see if that behaves better now. See if we are at least getting some verts being merged together. And catch up with chat while we wait in the build. Yes, Triangle World is gone. Dalos, what does stale Cool Ranch Doritos taste like? Like, do they get stale? Or, like, do they just already come pre-stale? Just now that I'm done. Alright, unmuting it now that I'm done eating candy. Sorry about that. So why does this look horrible here, right here? Let's put this in. I'll put in a start location on this too, so that I can always teleport back to this horrible place right here. Okay, so I'm going to set up some just easy parameters. So let me make sure I'm debugging the right level of terrain. And so I'm adding in a little bit of debug hooks so I can get a break when working on specific vertices. Okay, so let's see, where do I want to put in a little bit of break on this? Start with just plain old advert. So, got one there. Get a breakpoint there. Alright, all the breakpoints in the world. Let's see how this goes. So, building. It should start up very shortly. So I have several things that I need to do to make the game load faster, or make the builds faster. And someday when I'm not super busy with all the things that okay, I should have gotten at least some kind of breakpoint from there. So let's take a look at what we've got for Vertex right here in the code where we are emitting it. Which is perfectly sane. off this breakpoint here. Let's see. I guess switch over to monitor mode so that you can see everything that I'm staring at in here. All my little windows. So it doesn't look like anything at all interesting is happening in here. So what we need is to take a look at how we assign terrain texture, or assign stuff to triangles. Okay, loop over. Start it up again. This is getting to be the really not very exciting part where I'm going, what's going on? And yet there are 73 people watching this thing fail. I'm going to celebrate that by eating candy with the mic off. Okay, so in the background behind me, that is a Bull working with Gabe on something that is probably about the editor, because Bull and Dave. So game's loading up now. And here we have that should have been a greater than all along, but okay, so problem number one we are truncating textures that don't actually need to be truncated, because here we just have 2 of weight 2 and 2 of... So this will get a whole lot better if we just so that definitely needed to happen in there. So right off, I think a whole lot of things are about to get better, because we're not going to be getting rid of textures that were actually we didn't even need to get rid of at all. And so just to explain what was happening in here, I was running through all the verts that a triangle was using and putting the textures that each of those vertices used into a list, and I didn't collapse it down, so I'd have several things using texture 2, several things using texture 3, and then we say, well, we're only limited to 4 textures, but it could be that we had, 3 entries for texture number 2, so we'd be chopping stuff off that didn't need to be chopped off. So, loading up the game again. Let's see what happens. So that actually looks dramatically better already. A whole lot of the nasty chewed up stuff is just gone. But we still have this little junk. And even if this doesn't have hard edges, it's still not nice. So, let's get a closer look at this. Oh, what's the right command? There. Get me out of the way. So this stuff in here looks pretty terrible. gotta say. Like, this is... So we're still a long way from looking good. On the other hand, this may actually be what Ben has done here. We may be doing our best at rendering something not so pretty. Yeah, fly around the world a little bit and look for horrible, gross things. But I think we may be doing better at least. Switch over to a different zone and watch Visual Studio lock up. So that's awesome. So we have another zone that's known for having utterly horrible terrain problems in it. So let's load that up and see how it does or does not look. So, and then this is with all the grass turned off, so there's more to be done for sure. Or, you know, the grass will hide a lot of this blotchiness, but yeah, wow, this is... So just for comparison, I'm going to load up the current client on the patcher. By clicking agree, you secretly agree to buy a copy of WinRAR. Okay, so here's... Oh. And I fell through the terrain. So get myself back up through the world. And fly my way out to parts of the world and take a look at what we got here, and just for comparison's sake. See, so we got, you know, these nasty little like jagged lines in there. So got grass hiding a lot of the stuff, but I'm gonna try and fly around and just spot problems. Ben's like thrown super dense grass in everywhere, but I'm still seeing like a lot of sort of less than good stuff. Let's see, can't remember if I've pushed my change to grass rendering yet. Yeah, so I can turn the grass off. And I'll stop creating grass as I run around in the world. So you can see some of these just kind of like really nasty, ugly things in the terrain that were happening. Let's see, where am I? And look in the other client. So fly over to the same general area. But overall, I'm seeing a lot less of just like the completely wrong stuff, which is nice. So flying over here to the same place that we were. And this is with my new client. There are places, lots of places where the terrain looks like what's probably coming out of Ben's terrain mod, but not a lot of places where it looks like stuff is just chewed up. Oh wow, that's beautiful. I'm getting color keyed in a bit aggressively. So, um, so yeah, looking at the same patch in two of them, you can see definitely like all this weird jagged triangulation artifacts, and none of that is here. So I think we're at a place where all the terrain looks... I'm going to fly around to somewhere else, and this is with the current client, just looking out for crap like that. It'd be nice if I could make a way to, have the two clients move together in sync, but... But still, yeah, that's more triangle artifacts. I think we've just about nailed these down. So I'm going to commit this code, and it'll be on Hatchery in a good 20 minutes for those of you with IT access. And actually, well, I'm going to pull out my debug stuff first. And then we'll be done. I can stop worrying about terrain and start worrying about abilities again, or possibly light and shadow. Let's see, assign text. Get rid of this little debug code, and any place that it's being used should become a compile error. No more terrain lines. And there's more optimizations that I can do on this, but it's good enough for Scott to film a nice video, and that's the most important thing, because we like Scott to film nice videos. So, I'm going to break for a little bit and probably go round up the day with Tyler and the art team and see what their next priority for making things look better is. So, all of you, thanks for hanging out. I will... where did the... Yeah, yeah, I am probably going to call it a day. I might possibly be online again from home, just if I feel like having company, because my girlfriend's busy sewing on her cosplay. But thank you all for hanging out, and, check out the results on Hatchery. The terrain doesn't have seams and gaps and weird lines in it, and everyone loves that. So, we will be back later. Bye.